Trail and ultrarunners, what is going on? What's happening? Welcome to another episode of the Koopcast. As always, I am your humble host, Coach Jason Koop, and this episode of the podcast is about ketones and their potential for use as an ergogenic aid, as well as an adaptive aid in an endurance context. I do not need to tell you that exogenous ketones are all over the endurance space at the moment. The research lead for HVMN, which is a producer of ketones, Lat Manser, was recently on the Single Track podcast, as well as a few elite ultrarunners like Dylan Bowman and Jeff Browning have recently become endorsers of the product. They also sponsor a number of different podcasts in the space, but not mine because I don't take any sponsorships. And one of the confusing aspects of this relatively new supplement in the arena are the myriad of claims surrounding the purported benefits. You just need to take a quick search on any of the websites from any of these manufacturers, and they will lay claim to their products improving anything from metabolic health to cognition, as well as athletic performance. And many of these claims are repeated, regurgitated, and amplified by the vast ambassador network that the companies have started to build up. So with that as a backdrop on this particular podcast, we are going to take a little bit of a different approach to the format. What we're going to do is we are going to review many of the claims, some of which are going to be taken directly from websites, podcast interviews, and social media accounts. And we're going to put these claims through the scrutiny of a scientific lens. So to lead this charge, I have enlisted the help of Brendan Egan from Dublin City University. Brendan is the head of school for the School of Health and Human Performance. His current research investigates skeletal muscle function and adaptation with a special interest in the synergy between nutrition and exercise interventions. His research group performs human trials involving both acute and chronic interventions for outcomes around both physical and cognitive performance, recovery, and adaptations. They line up perfectly with all of the claims that many of the ketone manufacturers are actually making. I will point the listeners to his great 2022 review paper on ketone use in sport, which is free and open access. A link to that will be in the show notes. Y'all go and check it out. But what makes Brendan really special that I did not know until recording this particular podcast is his ability to weave the practical and mechanistic aspects of many pieces of research together and communicate what they actually mean to the end user. As we go through this, I want the listeners to remember that we are attempting to put claims and statements into their proper context. So, when applicable, I'll actually read the claim or statement directly and provide a link to it in the show notes. Sometimes those claims need to be generalized, and I will point out when they actually are. As I also mentioned previously, many of these claims have been repeated and amplified by the Athlete Ambassador Network. And none of this dialogue is personal, it is just professional. What I want the listeners to come away with is both the discernment of marketing and reality with these products, as well as some realistic use cases based on the current evidence. And finally, stay tuned for the outro of this podcast, where I will provide some color commentary on the landscape as a whole. You certainly will not want to miss that. Okay, with that out of the way, I am getting right out of the way. Here's my conversation with Brendan Egan. Thanks for joining the podcast to start out with. I appreciate you taking time out of your busy day. You look like you're in your office right now. I want to start out with, I did do a little bit of background on you, as I do with all of my guests. And I know sometimes that can be revealing for the guests themselves, because sometimes you don't know how your work gets like proliferated out in the space. And even before you jumped on the video call today and I saw you for the first time, the first thing I thought was, this person has produced a lot in a short period of time. You're seemingly very young. You and I are probably right around the same age. You're probably a little bit younger than me. And your name came up constantly with a lot of metabolism studies across a wide range of both scenarios athletes, firefighters, athletes of all kind of like different types and things, and also across different scenarios within what you were actually studying. And I kind of just want to know, like, how did you get into this? How did you get into the space, and what's kind of allowing you to have such a prolific like PubMed search right off the gate?
Yeah. Okay. So funny enough, I don't think I'm that prolific, but it's interesting to hear you say that. But no, certainly in the last number of years, my research group's output has definitely increased. So yeah, in terms of age, yeah, I'm 40 actually. So, but I've been a group leader. Let's say having my own research group since 2011, so over 12 years now. I was relatively young when I finished my PhD and did my postdoc, and was lucky to get into a faculty position fairly young. So it takes a little bit of time to ramp up, at the start, because in Ireland, at least, much of the work is lecturing and teaching, and your research is it's important for career development, but you're paid to teach basically. And so it takes a little bit of time to get all that in order and then begin to sort of ramp up the research side of things. But I've just been fortunate to have good collaborations, particularly coming out of my postdoc with Julian Zirath in the Karolinska Institute, and that's where a lot of the molecular work that I would have done came from. And then more recently, it's funny. A lot of researchers go down the route that they just focus on one thing and they become kind of known for one thing. And I actually have to say, that never really appealed to me. And I was much more interested in when talented students or postdocs come along and they've got an interesting question that's related to my area of expertise, and we just go out and work on something interesting, if we can get funding, of course. So in some respects, you sort of, you're complementing my, the sort of range within my CV. Other people would say, what's this guy working on now? It seems to be all over the map. So it just depends on your perspective. But no, look, what we try to do is work on interesting practical questions, apply the best we can from a scientific design point of view in terms of rigor. And what you'll notice in several of my studies is that when we go to test concepts that are floating around as being promising, or supplements that are thought to be beneficial, oftentimes we find there are no benefits or no signal out of the noise there. And that I would say that that's just due to the fact that we approach these projects with with an open mind. Like, is there a difference here or not? Putting the best methods we can, and whatever the data turns out to be, that's what it is.
And that's one of the things that also has kind of come out of your work, as far as what I can track from it chronologically, is something comes up in the marketplace, it starts to enter the popular vernacular and in people's headspace as they see athletes take it on. And even a lot of the Olympic sport teams are early adopters with interventions and supplements and things like that. You guys take it, you look at it, and you try to like pop the hood open and figure out what's going on underneath, either from a mechanistic level and or from a performance level or even a molecular level. And I've always appreciated that back and forth, because from a sports science perspective, we want to be on the leading edge, right? We want to kind of be on that very instant that something comes out that might have some degree of efficacy. You want first mover position in that, because 6 months down the line, everybody's going to be using it. And, you've then kind of like lost that advantage. So I've appreciated that follow-up that you guys have done in your research, and which kind of brings us to the topic today, right? Which is ketones. This is something that's popped up across the popular space in a lot of different areas, a lot of different contexts. I follow a few of the mixed martial arts nutritionists, and it's been a supplement that they've used in a variety of different contexts, from performance to their weight cuts to appetite suppression and things like that. Your lab has picked up on this. Was there any sort of genesis with that, where you guys were kind of like looking at this and said, okay, we're going to design a number of studies and look at the effect of ketones in an athletic context?
Yeah, and it's exactly the way you describe it. We had been hearing for a couple of years around this idea of these ketones being used across the pond in the UK. And, as it turned out, when the press reports came out, and they were probably only a few years ago that they began to talk about the fact that British Cycling may have been using ketone esters as early as 2012. And like, it's a newspaper report, it's probably in the Daily Mail. We're not really sure if it's true or not, but certainly when we began this work, it was 2016. And at the time that we began the work, a talented student had come to me, Mark Evans was his name, and he had the benefit of being able to receive funding for a PhD where the topic wasn't defined. And that's kind of unusual nowadays. Yeah. Usually you obtain funding based on a proposed project, whereas he had received a studentship within University College Dublin, where we were based at the time, to just do his PhD with me and no defined topic, which is the best thing in the world when it comes to trying to work on an interesting question. So we had both of us knew people who'd been working in the UK, particularly in elite sport, who had talked about the fact that, basically we knew ketone esters were being used. And that was, like I said, that was 2015, 16, when we began that work. And you bring up the point about, we've tried to be at the cutting edge and do things that people are talking about, but we're already a couple of years behind at that point based on what we now know. And that does tend to be the case, to be honest, is that with the best will in the world, researchers who are trying to work at the cutting edge are actually a year or two behind what pro teams and pro athletes are doing. So we're doing our best, but, there's always a bit of a lag time there. And in fact, just again, purely because the way research and PhDs tend to go, Mark had to write a really long literature review prior to getting any experimental work done. And again, that delayed us by even more, although of course the review was an excellent piece of work that he put together. But so it just landed literally the combination, the good fortune of a PhD studentship that didn't have a defined topic, a student who was interested in kind of pushing out the boat, and us hearing on the ground that these ketone esters were being used, and just putting it all together and developing a body of work around that.
And body work is a great way to describe it, because since then you have published several studies as well as reviews on the entire, not only your research, but the research across the entirety of the landscape. I'm going to start out the research part of this by something that you've done the most recently. In fact, 2 weeks ago, as of the time that we're recording this on August 11th, this is something that just came out where you looked at acute ketone ingestion without co-ingestion of carbohydrates and its impact on running economy. First off, really well done study, solid methods. I really appreciate the study design here. And that's not easy to do, especially with a nutrition intervention like this, where you're very trying to tightly control what's going on within the blood. Why don't you describe to the users like what that study design was, so hopefully they can appreciate how good it is. And then what you guys found specifically with running economy in this type of intervention.
Yeah, so the first thing I do is give a huge amount of credit to Aidan Brady, who's the first author on that. Aidan is a postdoctoral fellow here at DCU, but he's got a really strong interest in endurance sports, and he's really good in the lab when it comes to physiological testing, lactate profiling, running economy, and so on. So this was right up his alley in terms of his skill set. And then obviously we married the question of these ketone esters with that, with his expertise. The premise behind the study was that we had been, and many others have been doing studies looking at performance outcomes. And more often than not, the approach that's taken is to combine carbohydrate with ketones and compare that to ketones alone, compare that to carbohydrate alone. And the idea there as well, everyone uses carbohydrate. That's the kind of gold standard or the optimum fueling strategy. Let's layer ketones on top of that and see if anything happens. And it struck us that very few people had actually done the more basic question, which is what actually happens if you just consume ketones alone. And it's out of the roughly 30 or so studies have been done on ketone salts and ketone esters. There's only a couple that have actually used a ketone alone condition. And we probably, again, we can, if you want, get into all the nitty gritty around the mechanisms as to why this might be the case. But there has been a suggestion that ketones would be a more efficient fuel, for want of a better word. Now, that's entirely dependent on them actually being used as a fuel in the muscle, and that's maybe up for debate to a certain extent. But in theory, at least, an improvement in efficiency, in other words, a reduction in the amount of oxygen that's needed to run at a given speed or to produce a certain power output, that in theory could be a consequence of ketones being used as a fuel. So we wanted to go right back to basics, and instead of focusing on performance, just focus on this question of essentially what is the metabolic response to exercise. And we used graded exercise in this case. When you compare optimal fueling, let's call it, in the case of carbohydrate alone, a combination of the two, and then the ketones alone. So that ketones alone condition is probably the novel aspect of this design, and it turns out actually to be the kind of headline finding, as I'm sure we'll get to in a second. So we were interested in the primary outcome of being running economy. Again, Aidan has quite a bit of interest in running economy and its ability to predict performance in endurance athletes. And we employed a graded exercise test. So one of the features is that we use long stage duration, so 8-minute stages at different running speeds. So 10 kilometers an hour, 11, 12, 13, 14 kilometers an hour. So not necessarily very fast paced, but again, we're not dealing with the elite of the elite here. We're dealing with competitive runners training 4 or more times per week. They had decent 10K times in terms of criteria as well. So, they're good club level, maybe national level in Irish terms, but not international or elite in that sense. So, and obviously to measure running economy, they needed to be running below the lactate threshold. So that was the idea as well of these slightly lower running speeds. But essentially across all running speeds, what we observed was an improvement in running economy. So essentially less oxygen being used per kilometer per hour of running speed. And that was evident within the ketone only condition. There was, compared to carbohydrate, the carbohydrate plus ketones was somewhere in between, but not statistically different from either one of the other conditions. And so what we can, kind of conclude there is that there's something a little bit different going on where, in terms of the metabolic response or the oxygen utilization when you have ketones only on board as opposed to carbohydrate plus ketones or carbohydrate alone. And the other thing just to point out is that these were fed at the time. They had a day of high carbohydrate feeding the day beforehand. They had consumed a relatively high amount of carbohydrate that day. So they weren't fasted or anything like that, which is typically done in studies. So it was a pretty interesting finding, one that we honestly hypothesized would be the case, although we were kind of struck by the fact that it looked like, pretty much every participant was, because we have the individual data points presented within the paper, they all seem to improve on the ketone only condition, which is a fairly unusual finding to see very consistent findings like that across a test like that. But again, I think it's a testament to Aidan's ability in the lab, but also the controls in the study, standardization, and the protocol that we used as well.
Well, and one of the other reasons that makes this so powerful, just from a sheer pragmatic standpoint, and I kind of look at this through my coaching lens, is that particularly in the road marathon crowd, running economy has been this king and queen maker of sorts. And people are trying to do everything they can to improve running economy. They're trying to find fast courses and use different types of nutrition interventions, kind of like this one. Carbon plated shoes a few years ago led into that controversy. And one of the reasons why ketones is such a hot topic is because of this potential economic improvement that you get during that you might be able to get during submaximal exercise. And to kind of summarize what you're saying is that you see it when there are only ketones available, but when there are ketones but carbohydrates, that effect is either not nearly as much or not any different as compared to carbohydrate only.
Yeah. And I think there are lots of, it's one observation, and there are lots of ways that the research could go after this. In one sense, when I say optimal carbohydrate, it's actually not optimal in the sense that we give 1 gram per minute. But as you well know, there are people who are doing twice that amount nowadays. Maybe not in running necessarily, but certainly in cycling, it's getting up there. So someone could easily come back and argue, well, actually, you didn't give them enough carbohydrates. So, they, do another study. But you get
there's always another one.
But and then in terms like the implication, which again we didn't make this we didn't say this, but I've heard people kind of come back with and kind of they say, well, you're not seriously telling us that we should just perform races on ketones alone. And we didn't say that because that study hasn't been done. But that is the obvious question is what would it look like if someone tried to race on ketones alone? And what we have at the moment, actually, which might be of interest to you and your audience, is we have a study ongoing at the moment where this is the logical extension of this particular study is that we're running endurance athletes for 3 hours on a treadmill at a kilometer per hour below lactate threshold. And the idea there is, again, it's not a performance test. It's ketones versus carbohydrate. And it's simply to see what is the metabolic response here? What are the GI responses? How do they feel? What's heart rate look like? What does the rate of perceived exertion look like? So we'll see what happens. But the point we kind of made in the paper is that okay, there's the evidence at the moment in a lot of the shorter duration and the higher intensity types of events. Clearly, there's not really an effect there, but maybe, just maybe, in endurance runners or ultra endurance runners, there could be something there. And so we'll see where the data takes us. But at the moment, that's where we're going with it.
I've always felt that when research comes out, and Louise Burke's research with the whole nail in the coffin and low carbohydrate thing several years ago is a really great example of this. But when ultramarathon represents so you're saying there's still a chance whenever we go through these different iterations, and it's only a byproduct of it's hard to study because you can't get people in the lab, or you can't get many people in the lab to run more than 3 or 4 hours. It's just your pool of people that can actually complete those trials is actually is kind of quite small. So I always give a little bit of a chuckle to it.
No, and it's true. We actually, what we did before doing this 3-hour trial, we actually wanted to do an ultra endurance race. We wanted to simulate a race, and I don't know enough about ultra endurance, so someone could think this is pie in the sky, but we were talking about getting people in, because usually in these types of designs you want to do a crossover design where the people act as their own controls. And Peter Hespel's group out of Belgium, they published an ultra endurance study earlier this year using ketones, but it was a parallel group design. In other words, you just had all the runners went out at the same time. Some had ketones, some didn't, and it's kind of hard to make inferences there around about the performance side of things. But Aidan and I were trying to get together this idea that we would just run people for 6 or 8 hours on a track round in circles. And, that was the naivety. We eventually talked to a few people like, no, that's not happening. Whatever hope you have of maybe put them out on a trail and that kind of thing, we're just having to run around a track. That's not really why they do this sport.
Yeah, well, here, we can pull it out a call to the listeners here, and we'll leave a link to get a hold of you in the show notes if they want to participate in that study. I think you'll be surprised. We're pretty good gluttons for punishment over here.
Yeah. And, but, the thing you go back to Louise's point, just from a research point of view, or Louise's study from a research point of view, they were flying people in from all around the world to compete in some of those, or to participate in some of those research studies, and that obviously was funded by the Australian Institute of Sport. So one of the reasons why it's sometimes hard to do this type of research in elite athletes is that if you want to take them out of their training programs, or if you want to bring them to a certain part of, again, in Ireland, we have a very limited pool of, elite athletes. So it becomes difficult to do the kinds of studies that, a lot of people are saying, why didn't you do this study? Why didn't you do that study? But I mean, it's just, it's the nature. We're not trying to hide anything. We just can't get them done. That's the problem.
I appreciate that context. I'm sure the listeners will appreciate that context as well. Okay. So there was a little bit in the background. There was a little bit of a ploy for using this most recent study as kind of a lead in. Brendan and I, we've been going back and forth a little bit on email in advance of this podcast to discuss how we wanted to kind of orient it. For longtime listeners of this podcast, you'll recognize that this is the second podcast that I've had about ketones specifically. And the first one I had was with Heel Paffe, who's part of Peter's group that you were mentioning earlier. I'll leave a link to the show notes to that if you want to go listen to it, because we talked about some of his research in the area. And in order to kind of differentiate the podcast, what Brendan and I came up with is this really kind of neat design. We were going to go through the research, but we were going to lead into the research through the claims that a lot of the ketone manufacturers are making. And, this does sound like a ploy for me to be salacious and all of this other stuff. But what I will say is, after being a professional coach for over 25 years, nutrition interventions always follow a very regular pattern when they're introduced into the commercial space. And that pattern is, there seems to be some efficacy either based off of observation or mechanistic data. Mm-hmm. That those observations and those mechanistic data is usually exacerbated or exaggerated by the manufacturers who are trying to sell them. And I don't blame them. They've got small businesses where, we're talking about they've got to, earn a living and things like that. I don't blame that aspect of it. And then the research comes in, as you mentioned earlier, Brendan, 2 years later, and we start to uncover some of the, not the truths and the lies, but just sort of more the nuance of how some of these interventions work and don't work. And there's a great example of that has actually kind of recently reemerged, and that's with sodium bicarbonate. This is an intervention that we used, maybe 20, 25 years ago. Just put baking soda in a glass, swirl it around. I used it when I was a very mediocre track runner in college, and I'd swig it 30 minutes before the race. And I thought that I got some sort of performance benefit from it. Turns out we have lots of research that backs that up, that you can use it in some circumstances, and it can be very effective if you get the dosing right and the intensity is right and all this other stuff. And now it's come back in another format with Martin's product. And so this is, I use that as an example that none of this is new or novel. It's the same pattern that might not exactly repeat, but it at least rhymes. So what we're going to do is we're going to kind of go through the claims as the manufacturers have either presented them on their website and or in interviews. We're going to play a couple of interviews or social media posts. I'll leave links to all of that in the show notes, so I'm being completely transparent. And then what we're going to do is I'm going to throw it over to Brendan to go through what the actual research says about this, and where there's maybe a little bit too much of an extension of the claim, and then where there are some actual threads of truth.
Yeah, let's go for it.
All right, we're game for it. Okay, so the first one is a little bit of a lead in to the recent research that you did. That's why we started out with it. The first claim is that ketones are the preferred energy source. And there's permutations of this preferred energy source that have started to emerge everywhere. Directly from HVM Insight, which is a ketone manufacturer, they are referring to it as a preferred energy source for the muscles. And in fact, I'm going to read the direct. Read the direct quote here. So your body uses ketones as a preferred fuel source, meaning your precious glycogen stores deplete less quickly. The permutations of this kind of exist in other different formats. And I'm going to play a quick clip from a podcast that a lot of the listeners are familiar with, since it's endemic to the ultrarunning space. This is a single track podcast with Finn Melanson. This is Lat Manser, who's the research lead at HVMN, describing this concept of a preferred energy source.
Because now we can confidently say that the brain prefers ketones, a failing heart prefers ketones, and ketones have certain signaling properties that may induce anti-inflammatory properties.
Okay, so I'm going to stop it there, because then there's a rest of the dialogue that kind of deviates from this preferred energy source. So if I'm a user out there and I'm a coach and I see something that, hey, this is going to be the preferred energy source, I view that as an athlete's going to take this in, and it's going to be first in line to be oxidized in order to create work output. So what does the research actually say about this preferred energy source? Because you have data that says, you know what, if you take it in, it's a more economical source of fuel, right? Which you could interpret that as quote unquote preferred. What does the rest of the research say about this particular topic?
Yeah, I suppose it's worth tracing where I think the term comes from, and then maybe how it's been extended or maybe misinterpreted. So if I say at which point are ketones the preferred energy source, I think that comes from the starvation studies that were done in the 1960s. So what they effectively show is that when people are starved, obviously ketogenesis is an amplified, ketone body concentrations in the bloodstream rise. And if you look at fuel utilization in the brain under those conditions, what you see is that effectively after pretty prolonged starvation period, ketones eventually become the dominant or preferred fuel, let's say, within the brain. But I say dominant and preferred there in the same light, because even if ketones are dominant at that point, it's difficult to say that they're preferred. Neurons may still prefer glucose. It's just that there's not enough of it around, and therefore ketones are making a fairly major contribution. And again, I don't know how much science we want to go into the background here, but the whole ketogenesis response in a period of low carbohydrate availability or fasting or starvation, it's a survival mechanism, because those ketone bodies do go to the brain and become, as I said, the dominant fuel source after a prolonged period of time. So that to me is where the background comes from, where people might talk about a preferred fuel source. But again, it may seem like semantics to be talking about which word we're using here, but I think it's important because it does get to the crux of the issue. There is one other example actually more recently that has become obvious, is in that's experiments that are being done now in failing hearts. So there's a lot of interest in the therapeutic value of ketone bodies for failing hearts. And the idea there is that in a failing heart, the contribution of ketones, especially if they're given exogenously in the form of a supplement or an infusion, they can become again a major fuel source within the heart and potentially rescue heart failure in that situation. So they're examples, like two fairly extreme examples of where ketones do become a dominant, or again, do we say preferred? We certainly say a dominant fuel source within those organs. So then in the case of muscle, and to your point, I'm an athlete, I hear they're a preferred fuel source, I should go out and get them because my muscle is going to use them. That's probably unlikely. The scenario, as best we know at the moment, is that back in the 70s and 80s, there was a number of studies that were done where they had people fast for various different durations. And there were a couple of studies with infusions of ketone bodies as well. And effectively in those studies, what was shown is that the contribution of ketone bodies to substrate or energy provision was around about 10% at the most. So I don't think anyone would say, but at that level, that would be a preferred substrate. In fact, what happens is that the more prolonged that a fast or a period of starvation proceeds, the less likely the muscle is to use ketone bodies. And they think that's to do with a kind of a auto-inhibitory effect of really high ketone body concentrations actually switch off uptake into the muscle. The idea that they're being preserved to go to the brain. So again, an obvious question then is, well, but what about exogenous ketone supplements? If you provide it as a substrate acutely rather than relying on fasting or starvation, could that impact on fuel utilization? And again, the early evidence there was from this 2016 paper that's very famous at this stage from Cell Metabolism by the group out of Oxford. And the finding that they had in that study was that ketones, when they were ingested as a ketone ester, were making a 16 to 18% contribution to energy provision during exercise. And that seems a little high to everyone based on the research that had been done in the 70s and 80s. And subsequently, it was clear they were totally open about it in their publication. They said there were some certain estimates and assumptions made in those calculations. When the same group then subsequently went back and measured the ketone body oxidation rate more accurately using tracer methodologies, it turns out that it's probably somewhere around 5%. And again, they're explicit in their paper where they say this is less than we previously found, and they explain a couple of reasons why. So if you pull all of that together, if we're talking about ketone bodies as a substrate during exercise and their utilization by skeletal muscle, we're probably thinking that even under relatively high concentrations of ketone bodies within the bloodstream produced by consuming, say, a ketone ester, it's still probably only going to be a maximum 10% contribution to energy provision. And it's still going to be carbohydrate and fat predominantly. Obviously, we know that lactate and amino acids can make small contributions as well. But I think the idea that it's a preferred or dominant substrate in skeletal muscle during exercise, I don't think that's backed up by anything we have to hand at the moment.
That was a brilliant walkthrough, by the way. I didn't expect you to kind of be able to merge both history and current. But here's what a lot of people are thinking, a lot of people that are actually using ketones. If I can get 10% extra, not extra, but if I can get 10% of my total substrate utilization from something that is not carbohydrate and not fat, isn't that additive? Meaning I don't have to take in up to 2 grams per minute, as we were mentioning earlier. There's a lot of GI distress that can be associated with that. Those are really high carbohydrate intake rates. If I can somehow offset that with a non-competitive fuel source, couldn't that potentially be an advantage? It might not be preferred. We can argue about those semantics, but couldn't that be a performance advantage?
Look, that's the great question in all of this, because okay, where do we attack this from? So in our hands, when we saw this improvement in running economy in that recent study, let's just assume that the contribution to substrate utilization was 10%. It was a very small contribution that ketones made, but enough to have an effect on oxygen consumption. And in that regard, you would say, okay, you're right. That 10% is something that could be meaningful to performance, because the percentage improvement in running economy that we saw was around about 3 or 4%, which you mentioned earlier about the carbon plated, the carbon fiber shoes. That's round about the kind of percentage improvement that people go crazy for. So if that 10% contribution to ATP or to energy provision from ketones has then a meaningful effect on running economy, then you're right. That 10% is a good idea. But you also make the point about gastrointestinal upset. So, early on there was some concerns about ketones causing GI upset, and in our hands as well, we saw one particular study. We saw really bad GI issues, but actually over the last number of years, I think the concerns about GI upset have kind of dissipated in relation to ketones, especially the ketone esters. So, go back to your point. If I could consume a moderate amount of carbohydrate and a small amount of ketones on top of that, but ultimately have the same performance. So again, now we're back to the question: is same good enough? So now we're back to the simple math here in terms of finances. Is simple good enough, or is same good enough if you're spending $60 an hour?
You're saying it's not worse.
So I think that these are all practical questions. These are hard to answer by research, because you're getting down to the questions of what coaches or what athletes would prefer to do. And even if we're not detecting differences within our lab protocols, but people in the field are finding them beneficial, or they're, for some reason like that, they've less GI upset, for example, by consuming less carbohydrate, but performance is the same, then there are many different nuanced considerations to have there in terms of how we would recommend them.
Okay. So this leads into another one of the claims, and I'm going to generalize this because a lot of the ketone manufacturers get to this in different with different vocabularies, and I don't want to make it a semantic debate. The use of ketones in an endurance application is glycogen sparing. We just talked about it. If it can be up to, it makes logical sense, right? If I can either take in the same amount of carbohydrate and then taking ketones on top of that, that means that proportionally I'm taking in, or I'm utilizing or oxidizing 10% less carbohydrate potentially. So what does the research say about that ingestion of ketones during endurance exercise is in fact glycogen sparing? And I'm going back to the old Tour de France stuff that initially started all the hype cycle here, because that was a big component of the dialogue around why the Tour de France riders were actually using it. So what does the research say?
So again, there's a sound mechanistic basis as to how the provision of ketone bodies would impact on carbohydrate utilization, and that's really what we're talking about here. Where the mechanism we're talking about is that you can reduce reliance on carbohydrate utilization because of the fact that ketones are there and making a contribution to energy provision. Or you could argue that they may, shift the balance towards using a little bit more fat, which is another thing that you see if you dig into the weeds of some of the papers. But it comes back to, I suppose, the question of how often has this been observed. So the mechanistic basis is to do with the way it's like the Randall cycle, as it's called, where if you have this extra substrate within the cell, that effectively there's inhibition on glycolysis, particularly at the level of the enzyme phosphofructokinase. So again, sound theoretical basis. What happens in practice? Well, there's really only been 2 studies that have looked at glycogen utilization in muscle during exercise. There's a lot of studies and including some of our own, where you see differences in lactate appearance within the bloodstream, and that's sometimes inferred to mean that there's been a change in carbohydrate utilization. But there's a couple of assumptions baked into that probably aren't safe to make. And so what we would say is, how many studies have actually looked directly at glycogen? Well, there's only 2. One of them showed that there was sparing, let's call it, or reduced utilization of muscle glycogen during exercise. The other showed that there was no difference. So both the studies were ketone esters. Both of them are roughly similar designs. One of them was out of the Oxford group from that 2016 paper that I mentioned. The more recent data comes from Peter Hespel's group. The big difference between the 2 studies was that they used different methods of determining muscle glycogen. So in the 2016 paper, where they saw an effect, a reduction in glycogen utilization, it was using a staining method, a kind of indirect semi-quantitative measure for muscle glycogen. And in Peter's group, it was again in a muscle biopsy, but it was whole muscle quantified using direct determination of glycogen. So where do we stand? We effectively don't know is the answer. We see some, again, if you take those 2 studies that measure glycogen directly and then say, well, what does the lactate data say? Well, it turns out that's very mixed as well. Yeah. So what we would say at the moment is, to sum up, sound theoretical basis, but very mixed results as to whether that is the case or not when it's actually examined directly within exercising muscle.
Which I think is always really interesting when it gets so mixed like that, because then, as you mentioned, you start to dig into what the research design is, and oftentimes what we're finding is that research design is relatively similar, with the exception of how they might actually be measuring the end product of muscle glycogen or maybe even lactate or something like that.
Yeah.
Before we leave this, we've kind of been focusing on the potential for ketones as a like a real-time ergogenic aid, right? It's either going to be glycogen sparing in real time, or it's going to be a more economical source of fuel. And their performance is always multifactorial, right? I mentioned this to our coaches and to our athletes all the time. It's never going to be one thing that unlocks performance. Yet this multifactorial phenomenon is part of the fascination with ketone supplementation. I can look at this bottle right here for those of you that are watching the YouTube version. This is just a 10 grams, 10 grams or 25 grams?
10 grams of ketone.
Yeah, it's a 10 grams of ketones, the ketone IQ shot that I can purchase at my grocery store. There's a grocery store right around the street. It's cost me $4. Yeah, it cost me $4. You know, it's not really that expensive right now. But interestingly, underneath the dosing, which I couldn't find earlier, 10 grams ketone supplements, it has 4 distinct features: energy, focus, athletic performance, and appetite control. And this multifactorial approach, right, is I'm using that as a lead into part of the fascination with it. So what can we say, since performance is multifactorial, it has to do with fuel utilization, glycogen sparing and things like that. If we're to kind of alchemize all of these, somebody's going to run a marathon, run an ultra marathon, and use ketone supplementation. What can we say about that performance alchemization? Is there a realistic performance benefit that we can expect to glean from use of this particular nutrition intervention?
Well, just to add more context to what you said there, I mean, the point I always make about ketone bodies is that they're an incredibly, I don't want to say powerful, but I need to come up with a better word, but, they do so many things to so many organ systems within the body. And it makes sense because, as I said earlier, the production of ketone bodies is a survival mechanism, the amplification. They're always being produced, but the high rates of production is a survival mechanism. So it's not surprising that the effects all over the body and fairly dramatic effects. So, if we weren't studying performance and there wasn't a controversy as such, there's so many interesting avenues for where these ketone supplements can be used. And like I said, I touched on things like, I mentioned heart failure earlier, but there are things like cognitive function in older adults. There's the whole anti-catabolic effect that we've talked about before. There's glucose lowering effects. I mean, there's so much going on, but we get the controversy is all in performance, of course. But to go back to your question about the performance alchemy as such, I mean, what we've studied a couple of times, and others have as well, is whether there's effects on cognition and various different measures of cognitive performance. I'm not an ultra endurance or endurance athlete, so I know less about how that would be useful in that context. But one of the studies that we had done was looking at decision making effectively in soccer players, having performed a simulated soccer game. And what we see there is it was a statistically significant mitigation of decline is the way we described it. So effectively, decision making got worse as the exercise, as the simulated soccer game went on, and we saw a decline. And that decline was actually prevented in the ketone condition. And, that's got, even though it was a very modest effect, it was like the difference between 4 bad decisions versus 2 bad decisions, over the course of this 75 or 90-minute protocol. But in team sport, so I'm kind of bringing it back to my own domain here. In team sport, 2 bad decisions could be a huge impact on performance. Yeah. And it's one of the things that I struggle a little bit with is that I've tried these ketone supplements in my own sport, which is Gaelic Games. It's a football, a form of football we play here in Ireland. It's like soccer with your hands, basically. And it's very hard for me to say what is the performance benefit, but it could come back to the things like, is the rating of perceived exertion less? Is their ability to concentrate better? These are the types of things that would matter in a team sport. Now, how that would affect ultra performance, for example, maybe there's some, better pacing strategy. This is one of the things we speculated way back when these first came out, is like, could pacing strategies be impacted? Could alertness or attention be improved, again, going across different terrain and domains and so on. And equally then, could that rating of perceived exertion, or could the elevation in heart rate, could these types of things be attenuated, the rises attenuated over time? So, yeah, in theory, it doesn't all have to be to do with utilization of ketone bodies by the muscle, But at the same time, across all those domains that I've mentioned there, there's not a huge amount of evidence that those are dramatically affected. If there's anything going on, it's very subtle and it's not consistent across studies. And again, 3 or 4 years ago, I would have been saying we've only a handful of studies, but as we, a recent review that we published at the end of last year, there's got to be 30 different studies now at this stage. And again, that's still very mixed in terms of a lot of those outcomes.
Yeah, it's just very weak, right? It's very weak and very mixed. And I'll point the listeners to a piece of research that we actually reviewed for our research newsletter from Heel Poffey and Peter Hespel's group that looked at this in an ultramarathon situation where they gave people exogenous ketones kind of throughout an ultra, and it was a lot. If you added it up, it was a $400 or $500 intervention at the end of the day. It was a big, could you imagine it's a 100-kilometer race? So it's taking people 10, 12, 15 hours to complete it. And the amount of supplement that they're having to use was actually a lot. And we actually totaled that up in our research paper. And they found the same thing that you mentioned, where there was a prevention of the cognitive decline based on very simple Stroop tests and things like that. However, going back to the mechanistic part of it, as you mentioned from the onset, the groups were not isocaloric. And in fact, the ketone group was taking in about 30% more calories than the other group. So half of you would say, well, we don't care, right? This is the ketone use kind of catalyzed to a certain extent greater energy intake during the race. It's, potato, whether it actually, whether the total energy intake is causing the mitigation of cognitive decline or the ketones specifically are causing the mitigation of the cognitive decline. You don't care as long as there is a mitigation of it. I get that. I totally get that rationale, but I'm like you, I kind of want to know the mechanism behind it. So I'll encourage the listeners, I'll leave a link in the show notes to check out that particular paper. And then if they're so inclined, they can check out our interpretation of that. Nice. Okay. We're going to leave the performance side just to move the dialogue along and go into another one of the fascinating areas that has started to emerge. And that is that ingestion of ketones can somehow amplify the adaptive response. And we know that there's a whole host of response that we're trying to get from the training process. That's the ultimate goal of training. Kind of doesn't matter how hard the workout is or how good the workout is. It matters how much you respond to it. And there's any number of different interventions that you can use to attempt to try to amplify the training response. People have tried to use cold therapy, right? Even hot therapy, sauna therapy, and things like that to amplify it. Nutrition interventions. It is a golden goose to try to chase around because you're getting more for the same work. You go do the same workout from one day to the next, and you get more out of the day that you did it with whatever intervention that you decided to use. And there's been one particular claim that I'm going to bring up, and this is from the Delta G site, so that we make sure that we're picking on the different ketone companies equally here, and that's it. And that's that it increases your endogenous EPO levels. And so I'm going to read this directly from the site to make sure I don't get it, make sure that I get it correct, and I'll leave a link in the show notes to where this particular claim is. It is and the claim is specifically increased endogenous EPO levels by 23%. Delta G ingestion has been shown to increase post-exercise erythropoietin concentrations, revealing a new avenue for orally ingestible ketone monoesters to potentially alter hemoglobin mass. Link to study here, and they have the study, and I'll put that in the show notes as well. This has been something that has kind of come up time and time again, where anytime you mention EPO response, and since most people associate it with a banned substance, their freaking light bulbs go off and go, oh my God, this is something that I've got to chase around. So what says the research about this particular claim that ingestion of ketone esters in a workout kind of context can somehow amplify the EPO response?
Yeah, so that was a really nice piece of work actually done by the guys out of the University of Bath, James Betts and Javier Gonzalez. And it was a study protocol where they had them exercise, and then in the post-exercise period, they fed them, traditional carbohydrate protein types of dosing. So 0.4 grams per kg body mass of protein and 0.8 grams per kg body mass of carbohydrate, and fed this on the hour for 3-4 hours as part of the recovery process. So that type of a design where you've got an exercise bout and you've got this kind of protein carbohydrate feeding as recovery, that's been used many times. We've even done a study ourselves looking at different protein sources as well. But what they did differently was to add ketones to the feeding on the hour for 2 or 3 of the hours that followed. and then they tracked EPO concentrations thereafter. Now, if you look at the design, it strikes me as it's probably a design that there's a couple of more papers to come out of, because the types of measures that are being done, it's likely there will be things like muscle glycogen or performance and different things after a short recovery period. But what this rapid communication, as it was called when it came out, was to show that as you described there, which is accurate, is that the endogenous concentrations of EPO were elevated in that post-exercise period. Now, how far you extend that claim is I suppose what's in question here. So the crux of your question there really is, does this translate into something down the line? And the answer is that study has to be done, because what we would see is those concentrations they're not too dissimilar to what would be found with altitude training, for example. Yeah. But if they're only there for 2 to 4 hours, is that going to ultimately translate into a similar response as going to altitude? That's the question that remains to be determined. But it's promising. And to be honest, an awful lot of research is done in this style, where researchers do an acute study, they make an interesting observation, and the question becomes, will this turn into a training effect? And in best practice, whether it's this group of researchers or whether it's another, they will follow that up with a training study where they basically repeat this strategy over and over again and see if there's a difference after 4 weeks, 12 weeks, whatever the case may be. The one bit of extra color to add, of course, is that, and I'm sure you've seen this, is that several, and maybe, I don't know, did Chiel talk about this when he was on your podcast, but they subsequently have now published a study, Peter's group, so completely independent to the acute study, where they show that in their 3-week overtraining study model that they've used before, that when they look at markers of angiogenesis and of resting EPO levels, that they see this improvement that would be kind of a logical extension of what was observed in the acute study.
We talked about that in the podcast. We did.
And there are some concerns in that group in that study again about the fact that there was no angiogenesis in the control group. And so, was there a true angiogenesis being driven by ketone bodies, or was it just the fact that the ketone condition was better able to adapt independent of ketone bodies because that particular group consumed more calories, again, a bit like what you were talking about in the ultra endurance scenario as well. So again, it's 2 studies of, and it's very hard to put a number on how many studies you would need to see before you'd be confident of this effect. But I think the preliminary evidence is quite interesting there in terms of what that might look like. But how long, if all you were getting was like a little 4-hour window after every training session of this elevated EPO, how many training sessions would that take before it would manifest as a meaningful difference? That's a big question, I think.
Well, and that's what I come down to with this particular claim. And because, we have a lot of experience using altitude interventions to get this exact same response and hopefully show up in an improvement in hemoglobin mass amongst improvements in other markers. But let's be real here. Hemoglobin mass is kind of like the thing that you're shooting for with an altitude intervention. Yeah. And the one thing that we've learned from this, and I just happen to have Oliver Gerard on my podcast talk about this very recently, is it takes a lot of altitude exposure to actually achieve that effect, like 20 hours a day for 4 weeks. Like that's a lot. And whenever I see these acute responses in erythropoietin concentrations, I come back to, is it enough for long enough to produce a reasonable adaptation? And we have a lot of studies to show that when it's not even just the altitude studies, go to pressurizing an airplane. You're at sea level, you go into a pressurized airplane, you're going to get an EPO response. But you don't see athletes flying around in airplanes in order to get an altitude intervention, right? It's illogical because the stimulus is not enough and it's not for long enough. And I use that as kind of a cheeky example to go, okay, I understand that we're seeing this. Nobody's doubting that we're actually seeing this as a physiological response to nutrition intervention. Is it actually meaningful at the end of the day? And personally, just based on my observation and experience, the meaning really draws out from how long does that exposure happen for, and to what degree does it actually happen for? And, you'd have to be taking ketones all day and training all day.
This is the point. So if we played out a best case scenario, let's just say that, at the elite level, tiny increments in outcomes are beneficial, and we're looking for percentage different, tiny percentages. Well, let's just say you undertook this intervention for a year, and after a year, you finally saw, a difference. but you're going to have spent basically $100 after every single training session that you've done for a year. It's going to be a really expensive intervention that's speculative. And that actually is just to touch on that point, it is one of the core issues with this field, is that most practitioners and coaches would be slow to embrace or to recommend that an intervention that costs that amount of money. Okay, in pro sports, pro cycling, maybe they just think, let's take a chance on this because a very small percentage benefit is worth the risk of the cost. But until the potency until the ketone esters, let's say, come down in price, or until the potency of other alternative forms of exogenous ketones improves, like cost is just a huge barrier to any of the things we're talking about here.
I agree. And just to tease the last topic that we're going to go over the different forms and some of the ways that this cost is actually coming down, more from an origin story perspective. But we're going to stay on the adaptive response bandwagon, because the next one is another hot topic. It has to do with mTOR. Everybody's favorite signaling molecule recently. You get mTOR from a whole host of different interventions. But another claim is that acute ketone ingestion is going to improve muscle protein synthesis after using it during a workout. Once again, really sexy thing to grab. Hey, I've got, I'm going to increase my hemoglobin mass and I'm going to have bigger, stronger muscles after the same workout. I mean, once again, I would take that. I would take that as well. I'm going to read the claim directly just so that I get it right, and I'll also leave a link to where the users can find it in the show notes so they can kind of like read it for themselves, and the link study. So everybody's operating in full transparency here. So the claim itself is delta G has been shown to increase protein synthesis and tissue regeneration when taken with a recovery protocol. I'm emphasizing the last part deliberately because I know that's where the conversation is going to go. Link to study here. We're going to link the study in the show notes. What say you, Brendan, about this recovery protocol and increases in protein generation?
Yeah, so the tissue generation piece, that obviously can't be backed up because that hasn't been studied. But it's what the implication of, a bit like we talked about the acute EPO response, and maybe that leads to hemoglobin mass and angiogenesis down the line. In theory, if you get repeated stimulation of protein synthesis, you would get tissue growth. That's actually the premise behind all of the high protein feeding type stuff that's done around resistance training and so on. To me, this is a really interesting topic. It's actually the one I'm most interested in. Is just we've never been able to do the studies. But when we were writing our big review in 2017, the initial piece of work, and we looked at some of the work that had been done in ketone bodies in the 80s, had been around anti-catabolic effects and things like surgery or disuse models. And there'd been one particular study that was just an infusion of beta-hydroxybutyrate that did stimulate protein synthesis by about 10% over the course of 6 hours. This was in the 80s. Sri Nair's group were behind it. And the magnitude of that change is very similar to what we'll be seeing with, say, a high protein feed. And so in theory, if we just take that, this is now, as I said, ketone infusion many years ago. But in principle, protein synthesis could be improved, but with acute increase in ketone body concentrations. So fast forward then to the study that you're referring to there, again, is from Peter's group, and from 2017, if I'm not mistaken. Van Doorn is the first author. And what they have done in that, as you say, the recovery protocol is very similar to what was mentioned in the paper where they saw this improvement in EPO. It's because it's a glycogen repeating exercise bout, let's call it, followed by carbohydrate protein feeding with or without ketone, the exogenous ketone monoester in this case. And so mTOR actually is not changed in that particular study, but the downstream markers markers as anabolic signaling markers from mTOR are actually increased in the ketone condition. So in that particular study, they haven't directly measured protein synthesis, but they've measured markers that are fairly tightly actually correlated with increases in protein synthesis. So it's not a major stretch to suggest that there could have been an increase in protein synthesis. And when we think about, as I said, that infusion study from many years ago, I think things are coalescing there. They do a nice job of some cell work as well, where they show a similar principle in that study. So my take on that is that, yeah, like I said, the tissue regeneration, that remains to be seen. But in principle, again, in theory, between the mechanisms around how ketone bodies could be anti-catabolic or they could be pro-anabolic, let's say, or anabolic, there's probably something in that requires more research. The conclusion of most of what we'll say requires more research. But I think that one is one of the more promising directions, actually. And like I said, it's the one, if someone said to me, you can do any ketone study you want right now, that's actually where I go with this type of research, because I think that's where that's where the strongest mechanistic data is. And again, would be a really interesting application if that was the case.
Yeah, I have kind of come to the same conclusion as well, is that there's any promise, it's not acutely, it's as a recovery aid, essentially, or an adaptive aid, as some of the research has suggested. Okay.
And I suppose the other thing just to bring up at that point is, of course, Peter's group, Peter Espel's group, has also done the work on sleep as well. So again, it's a one-off study so far, but if I was an endurance athlete who trains in the evening, and the cocktail there seems to be ketones after exercise, ketones before bed, and everything is fine.
It's a great business model, because
someone's going to cut that out and make it sound like that was an endorsement, but no.
It's a great business model because you get ingestion before, during, and after. I don't claim to know what their profit margins are, but it's an expensive product, as we mentioned. That cost of production will kind of come down. Yeah. But
like I said, anyway, to sum up, all joking aside, I think there's some merit in there, but like to extend the claim out to be tissue regeneration, I don't think that's the case right now. No.
Okay, perfect. Okay, so we're going to move on to last topic and try to sort through some of the confusion around the different forms that are starting to emerge. And I want to use this as both a window into the present, but then also maybe a potential window into the future, because this is not a static proposition, right? I mean, nutrition science changes daily. We were just talking about encapsulating sodium bicarbonate, which I used 25 years ago, almost 30 years ago now, 30 years ago, encapsulating it in a hydrogel, and so that the food science changes. And this is an area that has changed recently, and I imagine will kind of continue to change. And the way I want to set this up is with my personal experience. So when ketones first came on the market, I bought a bottle of HVMM, and on the front of it, one of the features that the company was pointing out is that it would put you into, quote, rapid and deep ketosis. And I have a chemistry background, so the way that I translate that chemistry background is that the ketones will enter my bloodstream quickly on the rapid side, and to a great extent, meaning the way that the ketones show up in my blood, that curve will be quite steep, rapid and deep. Fast forward to today, and the same company has produced another format, another delivery mechanism, essentially, of ketones that has a slightly different spin on it, where and I'm going to stylize the way that they've described it to a certain extent. So some people might take a little bit of an exception to this description. To where the appearance of ketones within the bloodstream doesn't have as steep of a curve, and it lasts for a little bit longer. So you're going from a short, steep curve to a longer flat one. They've engineered the product, so to speak, to achieve this result, or the product that has been engineered has achieved this result, I guess is a good way to put it. I'm going to play a clip from Instagram from the HVMM CEO and co-founder Michael Brandt, kind of describing this process. And then I want to put this morphing of the different forms kind of with a science lens on it, and why we're starting to see this and what the kind of the biological effect might be. So let's let this clip play for just a little bit. And then Brendan, I want to get your kind of response to it.
With the United States Department of Defense Special Operations Command, looking at ketones specifically. And here's what we've learned. You already know that elite military operators, professional athletes, entrepreneurs, and people from all walks of life are using ketones as a super fuel to level up and hit their goals. So what's the most effective way to get ketones? The state of the art of ketone delivery is something called a dial. The pure dial that we put into Ketone IQ converts nearly 100% into blood ketones. The dial turns into blood ketones at a speed, duration, and magnitude that are optimal for physically and cognitively demanding missions. You may have also heard of something called ketone esters, which are diluted forms of the dial. The pure dial is what you really want. Ketone esters are chemical bonds between the dial and other less effective molecules. These other molecules cause performance drawbacks and digestion issues. Ketone IQ is our second iteration in the HVMN ketone product line. Our first version was actually an ester. Through our contract with the Department Department of Defense, we identified that the dial has the ideal performance characteristics for physically and cognitively demanding tasks. Because of the scale that we've reached with Ketone IQ, we've been able to bring down the cost per gram to less than 1/3 any of the esters on the market, despite the fact that the esters are diluted versions of the dial in combination with less effective ingredients. So not only is Ketone IQ the Ferrari of ketones, we figured out a way to do it at a lower cost than any of the less effective options. So there you have it. Our mission at HVMN with Ketone IQ is to make ketones universally accessible so that anyone in the world can have them and fuel you towards whatever your goals are in life.
Okay. There's a lot to unpack there, and I'm going to disregard the super fuel and the Ferrari analogy and all those other things. But to put a synopsis on it, the ester version is either bad or not effective. And the new diol version that was a byproduct of all of this, big military contract and things like that, is more effective for physically and cognitively demanding tasks. And you can hear a little bit of the dialogue that I was trying to fumble through earlier, where the curve of how the ketones actually appear in the blood is actually altered by altering the chemical composition of what you are actually ingesting. I don't know where to start with this. So I'm going to let you take the floor without any sort of preface on this one.
Yeah, I agree. A lot to unpack, and I guess if I'm going off on a tangent, pull me back in here. But
tangents are encouraged. I
think the place to start is to describe the esters and the so-called diol, just so that kind of background information is known. So throughout what we've spoken about today, it has almost exclusively been us talking about the studies that have used ketone esters. And there are several other exogenous ketone supplements, ketone salts, MCTs, butane diol, which is what we're going to talk about here now. I think it's probably not worth getting into all the details there, but just so listeners know that pretty much everything we've been talking about is a ketone ester up to this point. And when we say ketone ester, what we mean is a ketone body, in most cases beta-hydroxybutyrate, esterified, so joined to the butane diol molecule. And so that's where the ester word comes from. It's because you've got two molecules that are joined together. The reason we just don't ingest ketone bodies themselves is because they're generally in their free form, they're low pH, they're acidic, they can't really be ingested in that way. And this is, again, research going back to the 70s, I think was when the first time esters were described. And they were used at that time for infusion, so for parenteral nutrition more than anything else. But these esters were effectively a means to be able to elevate ketone body concentrations without ingesting the free ketone body itself. So the butane diol molecule is interesting because, as described in the video, it does increase ketone body concentrations. So the way I try to get people to think about ketone esters is that it's a molecule that has two other molecules bound, esterified together. When it goes into the body, there's enzymes called esterases that break down that bond. There is a certain amount of the rise in ketone body concentrations come from the beta-hydroxybutyrate itself. And then the butane diol that's present there, that goes to the liver. There's a complex metabolic pathway that eventually produces more BHB. And so the two things combined are better than either one alone. So when we talk about ketone esters, the reason, and you mentioned this about, rapid and so on, like that is kind of the thinking behind why the ketone esters have their prominence that they do, is that they do increase ketone body concentrations rapidly, and they do so in a fairly reproducible dose-dependent manner. So you can actually titrate the level of the concentration of ketone bodies in the bloodstream fairly well just by, dosing in per milligram, on a gram basis or per kg of body mass. So with all of that said, then the question becomes, like, why all of a sudden are a company suggesting that this ketone ester, which everyone's been using, has been used in most research studies, why removing the ketone body and just providing pure butane diol, why all of a sudden would that be, as they use it within the video there, why would it be optimal for physical and cognitive functions or challenges? It's something that's hard to make sense of, because of the two studies that have been done with pure butane diol and performance, neither of them have shown any benefit. So these were studies that were done around about, I think, if they're not both dated 2019, it's 2019, 2020. And both of these studies effectively showed no benefit. And in fact, in both studies, they talked about GI upset, about wooziness, and so on, because effectively sometimes the butanediol, the effect on metabolism can be to have a kind of alcohol-like effect. It's often something in the papers will often say narcotic-like effect or alcohol-like effect. So when the in that video where they kept referring to diol, effectively that's the butanediol molecule. So it's not a new molecule as such. It's just, and it's kind of alluded to in the video, that it's the other half. It's one half of the ketone ester. And so to say it's better than ketone esters alone, I can't see why that would be the case. And then the other implication within the video is that it's the pure diol that you want. You don't want the BHB because that's, I forget what the exact wording was, but it's basically a bad thing. And again, I'm not really sure how you can reconcile that claim with any of the evidence that's there at the moment, because yes, you can't consume the free BHB in the way that it would be in the form of an ester, but I don't think that that's the same as saying that if you consume it, it's the bad thing and the butanediol is the only thing that you need. That doesn't tally with what we know so far about the molecules.
And so just to backtrack a little bit for those of you that get lost in the chemistry lesson, which once again, I have a chemistry background and I still get lost in the chemistry lesson. The diol format is what you are actually seeing in the new ketone IQ product. They changed the name of it as well. Yeah. Versus the ester, the pure ester form is the first iteration of the HVMN product. What's in delta G? Because that's the Oxford.
So I should have
the Oxford of ketones.
So the context here is that HVMN had licensed sale of the ketone monoester. So most of the time when you hear refer to the ketone monoester, it's referring to this beta hydroxybutyrate butanediol ester. So it's those two molecules that I mentioned. So HVMN originally licensed that for sale in the US, and subsequently I don't know what the ins and outs of all these agreements are, but it's now been sold under the Delta G name. It's the same molecule, same ketone monoester, but essentially it's now been sold by the Oxford Group and their spin out directly. So HVMN no longer sell it, and instead now they sell this ketone IQ, which is, you rightly say, is the butanediol molecule itself.
So I don't want to get you to speculate because we don't know the business kind of ins and outs and things like that. But if the diol form is less effective, what would be the rationale to promote this? And this product is being promoted heavily. Let's not let's not like beat around the bush with that. They're dumping a lot of money into promoting this product across every single platform that you can think of, podcasts, social media, you kind of like sponsoring athletes or a number of different ultramarathon athletes that will be recognizable to the audience that have taken sponsorships for this particular company. If it's not as well studied and potentially less effective than the original version, why the change to the second one, other than I can get it in my Sprouts for $4?
Yeah, well, I mean, they do make the fair point is that it is cheaper, and it is cheaper than the ester. So the argument might be, well, if it's less effective at, say, increasing concentrations, why not take more? And so you'll ultimately pay less, but you'll get to the same concentration. I don't know if they ever say that, but I mean, that's maybe the logic you could use. But the problem, to be honest, is that if you consume, this is personal experience as well, if you consume a lot of butanediol, like, it's a fairly woozy feeling, know. It's I wouldn't say it's the equivalent of being drunk, but there's a bit of a buzz. And again, a lot of people talk about it. I mean, there's I sometimes wonder if it's like the feel good factor. We used to talk about supplements, back when contamination of supplements was fairly rife, back in the 90s and early 90s, before all the testing came in. It was well known that companies used to put in a hit of caffeine, or it could be ephedrine or whatever. There was this so-called feel good factor. Exactly. So I think I'm not saying that that's what HVMN are doing here, but I think when people are consuming something like the ketone IQ, the butanediol molecule, you do get a pretty buzzed effect. So like the one of the companies we haven't mentioned that are in this space as well is Ketone Aid, and so they also sell a version of the ketone monoester, but they also have a range of products that they call hard ketones, which is effectively butanediol styled in the context of an alcohol-free buzz, And again, like, it's the dosing. If you once you go above 10 to 15 grams as a single dose, in my experience, and again, people I've let try here in my office, there is a bit of a buzz that you feel. So maybe it's the feel good factor, but certainly from a performance point of view, as I said, the couple of the studies that have been done on butyl, it's obvious that it's difficult to get ketone body concentrations up to a level that we think would be beneficial during exercise without the downside effects of GI discomfort, wooziness, and so on. And so, unless they bring some of those, some studies to the table where they show performance benefits, I don't know how much longer they can continue to talk about it as a performance aid.
Well, and you just touched on one of the things that I kind of really want to wrap up with is that it appears to be that if there is a performance benefit, this is my emphasis that I'm putting on it, that if there is a performance benefit, it's a really tight window to thread from a biochemical standpoint. You have to get the blood concentration you have to get ketone blood concentration in a fairly narrow range, and you can see that emerge in the research where they're setting up the research protocols to be in a very narrow range, realizing that below they're probably not seeing an effect, and then above it might actually kind of be a negative effect. Whenever that's the case in the real world, that's hard to pull off because first off, you normally don't even have the measurement tools, right? Yeah. Just think about, how problematic it is to use a continuous glucose monitor, which is really, they've been using that for years in a diabetic population, and it still has yet to proven its worth in an endurance application beyond very limited kind of situations. So I look at that very narrow threading of the needle, so to speak, from a pragmatic standpoint, that the intervention that you have to apply has to be so precise for a maybe, for a big maybe performance benefit, and the potential for a negative part of it if you screw the intervention up. I kind of like, even if the maybe were true and I knew what it was, say it's 2%, right? I'd trip over myself. I'd do a backflip for a 2% performance improvement. You'd get that all day. But if I have to completely convolute the situation around it in order to get it, and if I know I screw it up, it's going to go negative 2%. I kind of take that value proposition on face and go, man, I'm going to leave this alone. Let's just go train. Let's just train more. No,
look, I think you put that excellently. I don't have anything to add on the specifics there, except just to frame the other side of things, which I don't know if in my introduction, if you'll have mentioned that I work in practice as well. So most of the time with athletes, they're so focused on supplements that they're missing the forest from the trees, in the sense that the other stuff around, energy balance and the right amount of macros and protein for recovery and protein at breakfast, all of these, we've probably got 9 or 10 more different, what you might call core features that you would want an athlete to do. And as you say, threading the needle on this extra, very specific niche concentration of blood ketone bodies, it's a very difficult thing to do. So, like you say, go and train, or go and get your other nutrition in line.
Yeah. Well, I think that's where we're going to park it, man. This has been awesome. I don't know how else to wrap this up. You have once again, we didn't know each other before this podcast. You have a brilliant way of weaving the narrative together in a way that is informative and logical, and also unbiased and pragmatic, so that the listeners can actually see through it. Neither of us have anything to sell. You work with athletes, you work in a research lab, and I've always appreciated people's perspective on it. So thank you very much. I hope that we get some additional subjects into your to be designed research studies. If they do want to participate or just learn more about you, Brendan, where can they find you and get a hold of you and harass you for more info?
Yeah, our papers are on ResearchGate if people just search my name. And the easiest thing is probably to search my name online, because I don't know if you came across the fact that I don't have a social media account. So it's not possible that way. But certainly if you search my name on Dublin City University, you'll either find my ResearchGate or my own personal page. And just I'm happy if people want to drop me emails and chat about ketones and performance or any other aspect of performance. I'm happy to do so. And hopefully I enjoyed this very much. So maybe in a couple of years' time we'll come back and revise what we got right and what we got wrong.
I'll tell you what, I'm always up for that. I don't always get it right. I've gotten it wrong plenty of times in my coaching career. That's for sure. People point that out to me on a daily basis. But if you have any research that's catalyzed from all the crazy ultra runners and that listen to this podcast, then you owe me another showing here. So I'll take you up on the offer.
Very good.
All right, folks, there you have it. There you go. Much thanks to Brendan for coming on the podcast today. I told y'all during the intro that he is a fantastic communicator, and he certainly lived up to that promise throughout the course of this podcast. Thank you, Brendan, for coming on and enlightening all of us, and I hope we get to bring you back on the podcast soon. I also promised during the intro of this podcast to provide some color commentary on the space as a whole, and we are going to get into that right now. This next little section it contains my opinions and my opinions alone, not the opinions of the guest or any of our other coaches that I work with or anybody else but me, the host. So if you have an issue with them, come at me directly. I certainly don't mind it. Keep that in mind as I'm walking through this. I want to get down to brass tacks for do I recommend ketones, and also down to brass tacks on the marketing side of it, both of which we touched on during the course of this podcast. First off, from ketone use as an ergogenic aid, this is a big no for me. And the reason it is a big no kind of falls along two tracks. First track is the performance track. And within that first track, there's two different prongs. I don't think that the research indicates right now that there is a performance benefit for using ketones within an endurance context. The second part of that is, even if there was a benefit, and let's just say it's 2%, roughly 2%, as we talked about during various points during the podcast. Even if it was 2%, there still is the potential that you can screw it up. And that potential is actually quite high because there are ketones in various formats. They affect the blood biochemistry and blood ketone levels to certain extents, and even have been purportedly manufactured to affect blood ketone chemistry differently. Because of this second nature, because it's hard to actually achieve the intervention in the first place, even if the performance benefit were true, I would probably still say no, because that is a very narrow thread to actually pull off when you're talking about a real athlete in the real world with a real situation. Just think about it. You can try this all in training that you want, but once you get out into a race and you have different foodstuffs in your system and all these other things are going on, it's going to be really hard to hit that optimal level of blood ketones that is purported to produce some type of benefit. So even if you could do it, it would still be a no for me. Just simply from a pragmatic standpoint, pulling it off, I think, is difficult and also rife to actually have the potential to make you worse. And as a coach, I want to make people better, not make people worse. My first kind of ethos is do no harm, going back to the Hippocratic Oath. Not that I'm a doctor or anything like that, but certainly from a coaching perspective, I want to put athletes in a situation where they're better, not worse, from the interventions that I'm giving. So that's a big no for me. Second part is on the adaptive process. And here, sure, maybe. I don't think there's enough research to indicate that there is an additional adaptive benefit. We're going to improve hemoglobin mass, or we're going to improve muscle protein synthesis or anything like that based on the current literature that is out there. However, there's likely no negative associated with that type of intervention. So if you want to go after it, go ahead and go after it. But I am not putting it not even near to the top of my list of things to do from a recovery or an adaptive standpoint. I would still rather have athletes focus on adequate calorie intake, adequate protein intake, adequate carbohydrate intake, adequate sleep, all of which we've talked about in previous versions of this particular podcast. Now we get into the sticky marketing side of things. And let me just be frank with everybody. The marketing coming out of the ketone manufacturers is disingenuous at best and flat out lying at most. And we touched on a lot of that throughout the course of this podcast. But whenever I see marketing that takes pieces of research and extends that research into claims that are no longer valid or don't have the right context wrapped around them, that's disingenuous. And here's why it's disingenuous, is that there are people within the walls of all of those companies that should know better. They should know the research. They should know the context that's wrapped around the research. And somebody should be an adult in the room and look at some of these claims and say, you know what? We are not telling this story in an authentic manner. This is not genuine marketing because we are distorting the research in some way, shape, or form in order to have a purported benefit with our particular supplement. Now, let me just take a personal example with this, because I could do this type of marketing within my own coaching practice. I just happen to coach several people who have won the Western States 100. I coached Casey Lichtig, I coached Ryan Sands, I coached Timothy Olson, who won Western States twice, and I coached Steph Howe. It would be a huge feather in my cap for me to say that I coach 4 Western States winners. And that is true. I coach 4 of them. However, it would be a disingenuous statement because the entire story is I only coached one of them, Casey Lichtig, when she was actually running. The other 3, I just happened to coach later on in their coaching careers. If I made that statement, I coach 4 Western States 100 winners, I hope that the community would roast me, just in the way that I'm roasting a lot of these companies, because that would be a disingenuous way to present what I have done with my coaching career in order to advance, in order to market it. It's something that I could easily do, yet if you look at all of the marketing that I've ever put out, you won't see anything related to any type of claim like that. In fact, I try to steer clear of taking credit for any of my athlete results, even when I am working with them during the time, of which I have had a lot. So when you see these disingenuous marketing claims, it should be a big red flag for you to run, not walk, 180 degrees in the opposite direction. And that is something that I certainly would do as a coach and as a practitioner in this area, not only with these types of supplements, but other ones that have run afoul with this in the past. That is my spiel on the marketing side. I hope you guys stay safe out there and you examine a lot of these claims critically and not take them wholeheartedly from the influencer crowd who tend to just repeat and amplify a lot of the messaging that is coming out of the companies in the first place. I hope you guys do take all of that to heart. I do appreciate everybody listening, and in particular, everybody listening through this extremely lengthy outro. If you like this podcast, please share it with your friends and share it with your training partners. If you thought it was interesting, you can share it with a ketone influencer and then ask them what they think. That should be quite fun. In any case, you guys, that is it for today. And as always, we will see you out on the trails.